Hello, ma'am.
How are you?
I'm good.
Okay. So let's revise what we learned in the morning session. Okay? Can you please answer?
Yeah, yes.
Okay. So what is gravitational force, Srivatsa?
Two forces which are attracted.
Hmm. Very
Two
good.
forces which are attracted by objects.
Yeah, the force of
Sorry,
attraction
the
between
force of
two,
attraction between two objects. The
two
force of
objects.
attraction
Yes. Having mass, right?
having mass. Yeah.
So we have indicated the gravitation force of attraction with F, and it is directly proportional to gravitation force of attraction is directly proportional to.
So gravitational force directly proportional to the product of masses.
Very good. Product of masses. So you can consider M1 and M2 or else capital M and small m. It doesn't matter whatever you're considering. Just you should know that it is product of two masses and inversely proportional to
And inversely proportional to
square of distance.
square of distance.
Yeah. So on removing the proportionality symbol, we are adding a constant which is G. What is G?
G, so G will be,
G for
sorry, G for gravitational constant.
very good. And the value of G is very important. So its value is 6.67 into 10 power minus 11 Newton meter square per, sorry, Newton kg per meter square. Okay. So what I'm writing. So the value Newton, yeah, F is equal to meter square per kg. Okay.
Yeah,
Clear.
yeah, sure.
So next thing, what else we have seen? So here we have two masses. We can also, yeah, two masses we can consider kg square as well. Okay.
Yeah.
So we have seen the properties and applications, everything. So what are the properties? It is a weak force. It is an attractive force. Okay. And what are the applications? Applications like we can see in the tides. We can see the revolution of planets around the sun. Yes.
Yeah.
Moon is also revolving around the Earth. Everything is due to gravitational force only. Okay, so the value of G, and we have seen that universal gravitation law, which was proposed by which scientist?
Newton.
Yeah, it is proposed by Newton. And the next point is the G. What is G here? G is universal gravitational constant, and its value is, and this is the value which is 6.67 into, and this value was found out by Cavendish, by the scientist Cavendish. Who was the scientist who discovered the value of G? He is Cavendish. Clear?
Yeah.
Okay. Now, what does universal mean? Universal means it is like applicable to everything. If we consider Newton's third law, what is Newton's third law? According to Newton's third,
Inertia, the Newton's third law will be, and
inertia comes under Newton's third law.
no, I mean, for Newton's first law. So Newton's third law, so I'll just tell the definition of Newton's third law. So Newton's third law is basically, for every action, there will be an equal or an opposite reaction.
Very good. That is Newton's third law. So now my question is, we have I discussed this point earlier also. Apple is there. So the apple, it is falling down on the earth, right? Because there is attraction between the apple and the earth. Yes or no?
Hmm.
Why apple is falling here? What's the reason?
The apple is falling there because
Because earth is attracting apple.
Earth is
Earth
attracting apple.
is attracting apple. Because of that apple is coming down. And I told you in between two objects there is always attraction. Yes?
Yeah,
If there
yeah,
is attraction in between two objects, if earth is attracting apple, then apple also should attract earth. Yes?
yeah, yeah.
It is not happening.
Nothing is happening.
Why it is not happening? Why only earth is attracting apple? Why not apple is attracting earth?
It's just because of the gravity.
Now it's just because of the mass. According to Newton's third law, this law states that the apple mass. So the mass is very small compared to the mass of earth. Earth is very bigger object, right?
Hmm.
Yes or no? The bigger
Yes.
one, it attracts the smaller one, but the smaller one cannot attract the bigger one. Okay. But
Yeah.
according to universal gravitational law, universal gravitation means it is applicable everywhere, irrespective of the mass of the object, irrespective of the mass, whether it is big or small, whether it is terrestrial or not, it doesn't matter. So there is attraction between the two objects always. Okay. What is
Yep.
universal gravitation? It is applicable to all bodies. Means the force, whatever the force is there, that is the gravitational force. It exists everywhere between the two objects, irrespective of applicable to um, irrespective of its size, whether it is terrestrial or not, whether they are terrestrial. Clear the point?
Yeah, it is clear.
According to this law, as the mass of apple is very small, it is not attracting the earth because the mass here, whatever the mass of apple, you are considering it as a negligible. There is nothing, like you're considering it as a zero. So because of that, it is not attracting earth. But coming to the universal gravitation law, according to this law, there is a gravitational force and that is applicable to all bodies irrespective of the size, whether they are terrestrial. Clear so far?
Yes, I'm clear.
Okay. Can we do questions on this formula, like numericals on this formula? You're clear? I hope
Hmm.
you memorize the formula well.
Yep.
Yes.
Yes, sir.
What
Yes,
is the
sir.
formula? F is equal to, repeat.
F is equal to G. GM. I mean, F will be equal to
Mhm.
GM M2 by D square.
Yes. And you should know each term, what it indicates, so that only you can solve the question, numerical. So what is F here? Please tell me what is F?
Gra F will be gravitational force.
Okay, what is G?
Gravitational constant.
Very good. And its value will be given to you. Otherwise, you have to use the value which you are memorizing. Okay, M1 and M2 are M1 and M2 are
M1 and M2 are
Mhm.
oops, sorry. M1 and M2 are
Yeah, these are the masses of the object.
the masses of the object.
Yeah, D is
Um, D is basically
D is
just distance.
yeah, distance between the objects. Let's see a question. So the question it is having find gravitational force. This you need to solve gravitational force between Earth and an object of 2 kg mass. Okay, given mass of Earth. So mass of Earth is given. Mass of Earth as 6 into 10 power 24 kgs and radius of Earth 6.4 into 10 power 6 meter. Okay. So now what we have to find in the question. So read question carefully. Find
Find
gravity.
gravitational force between an object between Earth and an object
So
of 2
what are the
kg.
two objects here
Earth and the
and the other one, right?
one.
Okay. What you need to find in the question? What we need to find in the question?
For the radius of Earth.
Read the question. Read question properly. What we need to find?
Find the gravitational force
Yeah. What
between.
we have to find? We have to find gravitation force. So find gravitation force between Earth and an object of 2 kg mass. So there are two objects. One is Earth, another one is another object whose mass is 2 kg. And mass of Earth is also given. It means whatever the two objects we are having, both masses are given. And radius is also given. And asking for gravitation force. Gravitation force is indicated by which symbol?
Gravitational force is indicated by symbol F.
Very good. It is F. It means we have to find F. F is question mark. So mass of two things are given. One is Earth and the other one is other objects. So we can consider one mass as, that is mass of Earth as M1, 10 power 24 kgs. Another mass as 2 kg. Understand? As
Yeah.
two masses are given, one mass I'm considering it as M1, another mass as M2. Understand?
Yep.
Next, radius of Earth. So radius is generally R. So whatever in the formula, we can also consider it as D given to us. So D is given as 6.4 into 10 power 6 meter. So by seeing all these terms, tell me which formula is used. Which formula we can use to find F?
To find F, it will be
Which
third
formula
one,
is?
of course, third one.
What third one?
I mean, it will be, D is equal to 6.4 to 10 to the power of BM. That is the one.
No, no. To find F, what formula we can use?
Force. So, mm by d square.
Yes. G M1 M2 by D square. So we should not miss this constant. It is very important. And what is the value of G? We know the value and you need to plug the value exactly. So what is the G value? It is 6.67. I told you to memorize 10 power minus 11. Units are Newton meter square per kg square. So the division part we can show with minus. So kg inverse 2. And one mass is 6 into 10 power 24 kg. Another mass is 2 kg. Understand? Whatever are there, I'm plugging the same things in the formula. D is 6.4 into 10 power 6 meters square. Meter whole square. Clear so far? Please let me know, Srivatsa.
Till now it is really good.
Okay. Whatever we did, so what we did, we just used our formula and we the given values in the terms. Okay. So first thing is you can cancel out units. Okay. Can I cancel kg with kg, this one? Or else if you are confused with this, you can use the same thing by. So can I cancel these three things?
Yeah, you can.
Because kg into kg is kg square.
Yeah, because kg into kg will be known as kg square.
Yeah, this is kg square by kg square and these can cancel. And here, what does whole square mean? Srivatsa, what does whole square mean?
Whole square, okay. So whole square will mean like it will be like whole to the power of 2. 6.4 into 10 to the power of 6,
There
which
are
is
two
4 to
terms,
the
right? 6.4 into 10 power 6 into 6.4 into
4
10.
into 10 to the power of 6. Yeah, that you're correct. That will make
Square
it
means
square.
we have to write twice.
Yeah, that will make it twice. That will make it a square by making it twice the numbers.
Meter,
Same.
meter, meter, everything get cancelled, and whatever the force finally you are getting, it is Newton. Okay.
Okay,
So
ma'am.
for gravitation force, so what is the final unit you are getting it as Newton? So obviously unit of force is Newton.
Yeah.
Okay.
Yeah.
So you're good at calculations?
Yeah.
Yes, can you do this? So what
Definitely.
6.67 into 10 power minus 11 into what is 6 into 10 power 24 into 2 by 6.4 into 10 power 6 into 6.4 into 10 power 6. Okay. How you are going to solve this, Srivatsa?
Yeah.
So,
So basically, we'll cancel whatever the two terms are there at up at the top and at the right side. So 10 to the power of minus 11, 10 to the power of 24, 10 to the power of 6, and then 10 to the power of 6 again.
yeah, 10 power
10 to the power
minus,
of 6 and 10 to the power of 6 will be cancelled. What about for 10 to the power of minus 11 also? This would be another 10 to the power of minus 11.
how it can be cancelled?
No, sorry. Oh, I thought it's about cancelling. No, it will not be cancelled.
So 10 power 6 into 10 power 6, that gives you
That gives me 10 to the power of 6 and another 10 to the power of 6. So
so what will
that will give me 1.
1?
Right. 10 to the power of 6 into 10 to the power of 6 will be like. Oof.
So
Yeah, I got it. I got it. 10 to the
we
power of.
write like this, right?
Yeah.
Generally, whenever you have the multiplication term, 10 power 6 into 10 power 6, what we have to do is add the two terms, 6 plus 6.
Yeah. Yeah, I know exponent law. It will be like 10 to the power of 6 into 10 to the power of 6. Generally, it is like this. It will be a product law. So 10 to the power of 6 plus 6 means the basis
10
will
power
the
12.
the basis will be same. Non like the powers will actually like oh, so basically the bases both are same and then the powers are also same.
No, no. When bases are same, powers are added.
Added. Then why did you
Okay.
put like yeah, they're same powers also? I thought.
Yeah. As they are same powers, we are adding. Okay.
Yeah.
10
Yeah.
power 12. Then what about the upper terms? We have 10 power minus 11 and 10 power 24. How we have to do this?
10 to the power of minus 11
Hmm?
plus 24.
Plus 24. Very
So
good.
it will be 10 to the power of 13.
Perfect. Very good. 10 power 30. So we calculated these terms. So, and what about the remaining terms? We have to do the same multiplication. What we are having 6.67 into 6 into 2. These are the terms we have. And in the numerator, I got 10 power 30. Am I correct?
Yeah.
By I have 6.4 into 6.4. These are twice. And these two together gave me 10 power 12. Correct?
Yep, correct.
Okay. Now, one is in numerator and one is in denominator. How we have to do?
So when one is in denominator and one is in the numerator, I have like now I have to minus it.
Very good. You have to
Minus the
mark.
powers. Now I have to minus the powers. 10 to the power
Yes.
of 13 minus 12.
Perfect. Which gives you
10 to the power of 1, which gives me 10 only.
10. Very good. Srivatsa, it is 10. Okay. And what about
Yes.
these? Do multiplication of the upper terms.
So it will be 6.67 into 6 into 2, which will be 12 by 6.4 into 6.4. So it will be a 6.67 into 6 into 2 by 6.4 square, whole 6.4 square.
Yeah. Multiply all these terms and tell me how much you are getting. In exam, you have to do. You have to
Sorry,
do.
yes, sure.
I think you are not provided with calculator in the exam.
I'm not providing any calculator in the
So you
exam.
have to calculate. Please take pen and paper and do.
Oh, yeah, I took the pen and the book.
Yeah, please. I think you're good at maths. Very good. That's okay. You can do later also. And its numerator value is, and you're having 10, and in the denominator you have 6 point whatever. So on final calculation, you get value of 19.5. And what is the unit we are left? All the units cancel and we are left with Newton. So final unit is Newton. So this is our answer. Okay,
Yeah,
clear? First
yeah,
thing, what
clear.
we have to write whatever are given. Let's sort out the formula which is used for the given terms and then substitute. Okay, so I'll be giving 2 to 3 problems for homework today. You solve on your own.
Yeah, yes.
Next, coming to the free fall. What is free fall? The definition. So freely falling. If any body or any object is falling down towards the earth due to gravitational force, that body is called as free fall body. So you can write the definition when objects fall. No need to write. So as I'll be sharing the PDF, it's okay. You can simply listen. When objects fall towards the earth under the influence of earth gravitational force, such object is called free fall. Freely falling object. So whatever the object which is falling freely, it is called freely falling object, and that particular motion is called as free fall, and the motion is free fall. Okay, if I'm dropping any object onto the earth, okay, this particular motion, the falling, this is a freely falling body, and the particular motion is called as free fall. Clear?
Yep, sure.
What is free fall? When object is falling towards the earth under the influence of gravitational force, such object is freely falling object and motion is free fall. Can you repeat?
No, I cannot repeat anymore.
Hmm?
Um, I have to copy the definition then first.
That's okay.
Definition will come in this.
Okay, sure.
Just need to.
So what you're saying is when a ball falls at the to the ground of the earth, that's what you're saying, right?
Yeah. Anything, any object, if it is falling down towards the earth, why it is falling due to gravitational
So
force?
it'll gravitational force. It is due to the gravitational force.
Yeah, because of the gravitational force, it is falling, and that object is considered as freely falling object, and motion
Yeah,
is free fall motion.
yeah.
Okay, and I told you object is falling freely. When it is coming down, there is certain acceleration. Okay, so the acceleration due to that particular gravitational force is called as acceleration due to gravity. Write down the next definition. Acceleration due to gravity, which is indicated by the letter small g. Now see the terms carefully. What is capital G?
Ma'am, your voice will go sometimes go low and sometimes it will come up. I don't know it's my problem here or that your side problem. So
No, I'm
don't
using constant volume.
Hmm?
Yeah, I'm not using any headphones. Directly I'm speaking.
Okay. Shivacha, your volume is 100%?
Is that good?
98%. It is good, ma'am.
Yeah, I'll come little closer and I'll okay.
Yeah.
Now, whenever you're facing the volume disturbance, okay.
Yeah.
What is capital G, Srivatsa?
So capital G, it will be bigger mass.
G.
Capital G.
So it will be like, oh, sorry, that one. It will be gravitational constant.
Very good. It is gravitational force. Next term we came across is small g. Small g is acceleration due to gravity. What is small g? It is
Acceleration due to gravity.
so. What is definition of acceleration due to gravity? Whenever object is falling towards the earth, whenever an object falls towards the earth, an acceleration is involved, and that acceleration is considered as acceleration is involved. This acceleration due to gravitational pull called as acceleration due to gravity. Okay,
Small g and big G.
so it is small g. So what is small g? Small g is whenever object is falling, there is acceleration involved in it. So that particular acceleration due to the involvement of gravitational force is called as acceleration due to gravity. Understand the definition? Can you explain me what do you understand?
So whenever an object falls towards the earth, an acceleration is involved. This acceleration due to gravity pull is called as acceleration due to gravity.
Okay, understand?
Yeah.
It is denoted by the letter G. So what is the unit of G? Unit. Unit is meter per second square. What is the unit? It is meter
Meter
per
per
second square.
second.
So here, what we are considering, an object we are considering, and it is falling on the Earth's surface. Let the mass of Earth is capital M, mass of object is small m, and the force involved according to Newton's law is G capital M small m by R square. This is what we discussed earlier, right?
Yeah.
Okay. According to Newton's law, you told me earlier Newton's first law, right? About inertia.
Yeah. Inertia.
Yeah, very good. In that law, what is the formula for F?
F will be equal to
Hmm?
GMM.
According to Newton's second
It will
law,
be GMM square.
no, that is the formula based on the universal law of gravitation.
Yeah.
According to Newton's second law, what is formula of F?
So according to Newton's second law,
The formula of F is equal to ma.
MA.
What is m here? M is mass.
Mass.
A is
Acceleration.
A
Acceleration.
is acceleration. Can I plug in the same formula of F here? Can I use here?
And F will be
MA, can I use MA in place of F because F is equal to MA?
yeah.
So I'm using MA here and the formula will be GM by R square. Can you see I'm using this formula exactly here?
Yeah.
So now which terms I can cancel?
Yeah, yeah. So the terms
Common
which can be cancelled
Common
are
terms which are equal on either side I can cancel. So M and M I can cancel.
M and M are cancelled, or either you can also cancel that M and that M also.
No. This is
Oh,
mass of Earth.
lowercase m you should cancel.
Yeah, this is mass of an object. Both masses are different here. Okay, and A is, I can write A as G because this is the acceleration which is involved due to gravity. As since A, I can write G, what G will be Gm by R square. This is the formula for universe acceleration due to gravity. Understand? What is formula of acceleration due to gravity?
Acceleration of gravity, right?
What is formula we got finally? G is
Ma
equal
G is equal to Gm by R
to
square.
R, right? So what is
Yeah.
M? See the terms. What are the terms here? G is equal to G. So whatever the formula we are learning, each term, what it indicates, those are important in solving numericals. Okay.
Yeah.
Let's write what is capital M here?
Capital M. Capital M will be equal to like
What we consider capital M as mass of Earth.
mass
Small m
of
object. So small m already got cancelled here. So we are left with mass of object, Earth. So capital M is mass of the Earth.
the earth.
Okay. What is G? G we have already studied. It is
Gravitational
Mhm.
force.
Gravitational
For constant. Gravitational.
constant. Very good. What is R here? R is radius of the Earth. Clear?
Yeah.
Okay. So now from this formula, can we say acceleration due to gravity is directly proportional to mass of Earth?
Yeah, we can say
Inversely proportional to what?
inversely proportional to um R square.
What is R? Very good.
Oh,
Radius of Earth.
so R will be radius
Of the Earth.
of the
What is
earth.
M? So I can write G depends directly on the mass of the Earth,
Then the mass of the earth.
which is capital M, right? As it
Capital
is
M, capital M.
proportional. And inversely related with
And inversely related with
radius of the Earth.
radius of the earth.
Clear so far?
Yeah.
Okay. Now I'm going to ask you a question. This is my Earth. Okay.
Yeah.
What is this considered as? What is on the Earth? What is the center called as? This line,
That will be the well, that will be the horizontal axis,
which is equator.
which is equal to.
Okay. And at the top, what you have?
And on the top, I'll have the
Pole,
poles.
which is North Pole and the South Pole. Okay.
Yeah.
So when you consider equator and when you consider poles, in among the two, where radius is more? What is radius? Radius is nothing but half. This is my radius, half of circle.
Yeah.
In case of equator and in case of pole, where radius is more.
Radius and diameter.
Yeah. In on the pole or on the equator, where you can see more radius.
I can like see more radius on the equator side.
Yeah, equator. On the poles, you have less radius. If radius is less, what about the acceleration due to gravity? So we can write on the equator, radius is more. Okay. On the poles, radius is less. If radius is more on the equator, what about G?
Gravitational constant.
Yeah, G will be less or more.
G will be like less. So on the top it will be like the more, and then on the bottom it will be less.
See the relation? Radius and G are inversely related. If radius is more at equator, G is going to be less. If on the poles, radius is less, so G is more. So you are correct. Okay?
Yep. Yep. So on the equator radius more, then the G is less. That means it's a small G. So if the on the poles the radius is less, the G is more. That means it's an inversely proportional.
Yeah. So what is this G called as?
So that G will be called as um uh, gravitational constant. It will not
No,
be.
capital G is gravitation constant. Small g
It will
is
be the
called
acceleration of the gravity.
acceleration due to gravity. Very good,
Accel-
Srivastava. Okay. So what is the value of G? G is going to be 9.8 meter per second square. Simply whenever we do calculations, we use 10 value. Okay.
Yeah.
So we have seen two values till now. One is capital G value, another one is small g value. So both values we should know. Okay.
Yeah. Yeah.
Yes.
Yeah.
Let's do a numerical. Okay.
Yes.
The mass is 6.39 into 10 power 23 kg, and that of Jupiter is 1.89 into 10 power 27 kg. If the distance is 7.49 into 10 power 5 meter, calculate force. So tell me what are given. Let us read the question together. So mass of Mars is given, this value, and Jupiter is given. So what are the two objects here? We are considering one as Mars, another one as Jupiter, right?
Mm.
So distance between them is given as 7.49. So what is the force? So which formula we can use?
So we can use like
What we need to find here?
I need to find the mass of Jupiter.
Read question properly. Mass
And
of
the
the
Mars, if the mass of Mars is 6.39 into 20, 10 into 10 to the power of 23 kgs.
hmm,
That of Jupiter is 1.89 into 10 to the power of 21 kgs.
hmm,
So the distance is 7.49 into 10 to the power of 5. Calculate the force.
hmm.
Force.
So we need to
G is
find.
equal to 6.7 into 10 to the power of minus 11
So
nm
what we
square.
have to find here?
So sorry, the formula will be like no. The formula is F is equal to um F is equal to
Hmm?
sorry, mm
Yeah, yeah, yeah.
gmm square by d square.
Very good. Perfect. So what is the value of G?
So the that G is known as the gravitational constant.
Yeah, value is given. What is the value? Whatever
Oh,
is.
so I mean that value is 6.7 to 10 to the power of minus 11.
Yeah. Next, what is mass value? Two masses are there and two masses are given. One you need to consider as M1 and another as M2. Because there are two masses, one mass, both the masses you need to use here, which is product. One is
So
639
first
into.
mass, the first mass will be like um uh,
We use two masses.
these two masses.
What is the
So
value of D?
the value of D is distance.
Okay, value is
Oh, sorry, the value is
which is 7 point.
oh distance is 7.49 into 10 to the power of 5 meters.
Yeah. So use as it is square, we have to write twice, right?
Yeah, as it is a square, you have to write twice.
10.5 meter into 7.49 into 10 power 5 meter. Am I correct?
Yep.
Okay, which units we can cancel here? Tell me.
So over there you can like cancel um 7.49
Units. See the units, Newton, meter square, kg, all the units.
kgs.
Kg we can cancel. Here there are two kgs and you can cancel two kgs. Then what else we can cancel?
Yeah, then what else we can cancel is mass, two masses,
This is not mass, it is meter.
meter.
Yeah, meter we can cancel. So finally we are left with the unit of Newton. Now let's do the calculation. Tell me the upper value, 10 powers value, how much you will get in the numerator.
So
So in the physics, you have to good at the numericals, the formula, deriving formula, using values in the formula, finding answer, all are very important in physics.
so yeah, 10 to the power of
What are there in the numerator? You can use your pen and paper and tell me.
yeah, sure. Now here is to
You are copying everything. Just tell me these numerator values.
Calculation, not to calculate everything.
so now we have to do 6.7 to 10 to the into 10 to the power
Yeah,
of
yeah.
9.
Tell me how much we get on calculating these three.
So after calculating
These
um
three together, how
those
we
three,
have to
those
write?
those three. So it will be 10 to the power of minus
Mhm.
11 plus 23 plus 27.
Perfect. So that gives you
So that gives me 39. 10 to the power of 39.
very good, Srivatsa. So in the numerator, we get 10 power 39. In the denominator, tell me what we have in the denominator.
And
10
then in the
power.
denominator, we'll have 10, 6 point, wait, 7.49.
Yeah. No. Tell me these two values. How much we get?
Oops, sorry. 10 to the power of
Mhm.
5 plus 5.
Mhm.
10 to the power of 10,
Very good.
which
So
will
we
be
calculate.
100.
And remaining these, you can do the simple multiplication process. Like 6.7 into 6.39 into 1.89. These already are there. I'm using the same. And the 10 powers totally give me 10 power 39. By I have 7.49 into 7.49 in the denominator. And I got 10 power 10. Now tell me calculation of these two, Srivatsa.
Now it will be a minus. So which
Very
will
good.
10 to the
So this
power of
is
29, 29.
29. So this you do multiplication of this and multiplication of this and then you divide it. This is like general maths. So I'm not teaching you this particular point. Even in physics and chemistry, calculation of these 10 powers is very important. Okay. I hope you're
Yeah.
good at multiplications and divisions.
Yeah.
You can do that. Clear?
Yeah, clear.
Okay. Next, I'll be giving like two questions for homework, which you need to
Yeah.
study for the next class.
Yeah.
For the class, you just post it, post your
Yep.
homework.
Yeah. Sure.
Okay. Okay. What is a free fall, Srivatsa? Free fall is
Fall is when like the gravitational constant
free
force for
fall. Free fall. What is free fall? The definition of free fall. When an object is falling freely towards the Earth's surface due to gravitation force, that body is free fall body and the motion is free fall. Okay, can you repeat?
so an object fall towards the earth under the influence of the earth gravitational force. Such object is called free falling object, and then motion is free fall motion.
Very good. And what is acceleration due to gravity?
Acceleration due to gravity. Whenever an object falls towards the earth, an acceleration is involved. This acceleration due to gravitational pull called as acceleration due to gravity.
Hmm. Can you tell me what is a free fall?
So free fall is when an object falls towards the earth,
Hmm?
then acceleration is involved. Is involved.
Oh no, what is free fall? Free fall.
A free fall. But you change the definition. So free
Hmm.
fall is like when an object falls. Sorry, when an object falls freely.
Hmm.
When an object falls freely, what can I call it?
It's not like exact definition. You just explain me what do you understand? What about
When an
free fall?
object falls freely, it is
Hmm. Freely due to how it
so
is happening? Due to
so when the object like falls freely, when the object falls freely due to gravity.
Yeah, due to gravitational force.
Due to gravitational force, the object is falling out towards the fall. The object is, I mean, the object is a free fall object.
Yeah, and motion is.
And motion is, so, and the motion is free fall motion.
Yeah, it is free fall. Can you see the definition again? When object falls towards the earth under the influence of gravitational force, such object is freely falling object and motion is free fall. Can you read? Can you repeat the definition?
So when objects fall towards the earth under the influence of earth, gravitational force such is, move your screen a little bit. Oh, I can only move. Such object is called free falling object, and the motion is free fall motion.
Yeah, very good. What about acceleration due to gravity?
So acceleration due to gravity.
Hmm.
So acceleration due to gravity is um I'll see. Acceleration due to gravity is when um due to the gravity the
Whenever object falls towards the
oh,
earth,
whenever an object falls towards the earth,
an
an
acceleration is
acceleration is involved. The acceleration due to gravitational pull, called as acceleration, is acceleration due to gravity.
okay. Read again.
So what, ma'am? Now you're telling me.
Please read again.
So when an object falls towards the earth, an acceleration is involved.
Hmm.
So this acceleration due to gravitational pull, called as acceleration due to gravity.
Okay, very good. So we have seen what this is the formula from the universal gravitational law, and again I'll repeat, writing the equation is very important. The expression calculation, F is G m by r square. This is formula we have from universal law of gravitation. From Newton's second law, what is formula for F, Srivatsa?
So the formula for F.
From Newton's second law?
For Newton's second law, the formula is F is equal to F is equal to ma for the first thing.
Very good, very
Right.
good.
So
F
for
is mass
even
in
that,
acceleration. What is mass? What is m here?
so m will be
Mass of what?
mass of momentum.
M is mass.
Mass of an object.
Very good. Mass of an object. Okay. In the universal gas law, capital M is what and small m is what?
Capital M is the larger mass.
Yeah,
and
mass of, here we are
smaller mass.
considering Earth. Okay.
And there we are considering like you can
Yeah.
consider it as a pen.
Yeah,
Ball, a smaller ball.
yeah. Here we are discussing the free fall motion. In the free fall, we consider two objects. One is any object, another one is Earth. So Earth is considered as the bigger object here, whose mass is capital M. And the free fall, the object is considered as small m, because we are deriving acceleration due to gravity here. Okay. That's what I
Yeah.
drew a diagram here. Can you see the diagram? We consider a free fall body. In this, there are only two things are there. One is a free fall body, another one is the Earth surface. Earth is a really big object whose mass is very big. So we are using big M, capital M. And the free fall object is very small and we are using small m. That's what we change the formula to derive acceleration due to gravity in case of free fall. Understand?
Yeah.
So this is mass of an object, even small m is mass of an object. So what we are doing, we are replacing this F with MA. So because of which we are writing MA in place of F and G here, capital M, small m by R square. Which is getting cancelled here, Srivatsa?
So which is what?
Which is the common term we are cancelling here?
The common term we're catching here is
Small.
smaller m and smaller m. That's
Yeah. And A is acceleration. As gravitational force involved, we are writing G in place of A. That's what the definition is, right? The acceleration which is involved due to gravitational force is called as acceleration due to gravity. So I'm replacing A with G. So G will be G capital M by R squared. This is the formula of gravitation due to gravity, whose value is 9.8 meter per second square.
yeah.
Okay, whose value is 9.8 meter per second square. From the formula, what we can tell, G is directly proportional to mass of an earth, mass of the earth, right? It is directly proportional. What about the radius? G is directly or inversely?
Yes. Inversely.
Yeah, inversely proportional to radius of the object, radius between the two objects or a radius of the earth. Okay.
Yep.
So what is R here? Radius
Radius
of the earth.
of the earth.
Okay. Where G is more at equator or at pole?
G is more at the equator.
Sure.
Oh wait, let me think. G is more at the gravity is more at the oh
So
pole
how
pole pole. Wait, what did I say? What was my previous answer? Pole only, right?
yeah. So in
So
the
actually
equator,
it is the equator. Gravity is more at the equator.
more radius. So G is less. At pole, radius is less. G is going to be more. Clear? Clear so far?
Yes.
Right? Because the G is inversely related to square of radius. So if as it is inversely related, if radius is more, G is going to be less. Clear?
Clear.
Okay. Please let me know if you have questions today's class.
No, I don't have any questions. Good.
I'll be sharing PDF. In the PDF, I'll include 2 homework problems.
Okay.
Please do them.
So bye ma'am.
Yeah. See you in the next class.
Bye. Good night.
Good night.